Today we're going to be talking about a type of reaction that we'll be using quite a bit and learning more about in the days and weeks to come. But today we're going to get a little bit of an introduction to what we call double replacement reactions and how they work and how we write them. So in a double replacement reaction, essentially what we've got is two ionic compounds react, and the ions swap partners is how I like to think about it. So our ion swap partners to form two new ionic compounds. So in really, really generic terms, we can say if compound AB reacts with compound XY via double replacement, you can think of it as either the cation switching or the anion switching. It doesn't really matter. But our ions are going to swap partners. So let's do this in a different color. One thing to keep in mind is that for something to be a valid ionic compound, it has to have a cation and an anion. You cannot have two cations together. You cannot have two anions together. So the way I've color-coded this, the pink ones, A and X, are my cations. We know that the cation is usually written first in the formula. And the blue ones, B and Y, are my anions. So it doesn't really matter how you think about it, but as I've drawn it, I'm taking the cations, I'm swapping their places. So that in my products, X is now going to end up with B, and A is going to end up with Y. But our products are still ionic compounds, so each one of them still has to have a cation and an anion, cation and an anion. So that's the only way that these can switch. And regardless of whether you think about switching cations or switching anions, you end up with the same products. So this is generically what's always happening in a double replacement reaction. So let's look at a more specific example. I'm going to start out in words, in names, and then we're going to write the formulas. Because I think it helps to think in names first, where you're just swapping the words. And I'll explain why as I go along. So let's think about the reaction that would happen between sodium iodide and aluminum nitrate. So in this case, we're given names. We know the cation is listed first. So our cations are sodium and aluminum. Our anion is listed second. So our anions are iodide and nitrate. So if we do the same sort of swapping partners action here, in terms of names, we just need to switch the words. So aluminum will end up with iodide. So our products will be aluminum iodide. And sodium will end up with nitrate. So we can say that sodium iodide and aluminum nitrate will react via double replacement to form aluminum iodide and sodium nitrate. Now we can translate this into formulas. So thinking about the charges on our different ions, Sure, we'll use red. Sodium is in group 1, so it forms +1 ions. Iodine is in group 7, so it forms -1. Aluminum is group 3, so it's +3. Nitrate is one of our polyatomics, so that one just is what it is, which is -1. And then all of those charges stay the same in our products. So aluminum is still -3, iodide is still -1, sodium is still +1, nitrate is still -1. So we need to think about these charges when we write formulas. And I find that when you get into reactions, this tends to be overlooked, which is why I like to think about it in names first, even if you don't necessarily write it out. Think about how things are going to be paired and then work on the formulas after. So for sodium iodide, we have a +1 and a -1, so a 1-to-1 ratio works great. So NaI is our formula for sodium iodide. Now for aluminum nitrate, we have a +3 and a -1. So in order for that to work out to a neutral charge overall, we are going to need 3 nitrate ions for every 1 aluminum. And since nitrate is a polyatomic, we'll put that in parentheses to indicate that this whole ion, there are 3 of, and put the subscript after. And then on the other side, aluminum iodide is +3 with -1. So we'll need 3 iodides for every 1 aluminum. And then sodium nitrate is +1 -1, so 1-to-1 ratio is great. So I think this way you are more likely to end up with the right formulas. What I tend to see if you just start with formulas is that people just take the Na and the Al and literally swap their places and don't change anything else. So if you just put Na in here, you have NaNO3, 3, which is not the correct formula for sodium nitrate. So the double replacement tells you which types of ions are paired, but it's still the charge that dictates the subscripts, that dictates how many of each ion there are, because it still has to come out to a 0 charge overall. So at this point, we have the formulas correct, but we can see that our reaction is not balanced. We have 3 iodine over here and only 1 on the left. We have 3 nitrate on the left and only 1 on the right. So to fix that, we can put a 3 in front of sodium iodide, which gives us the 3 iodides on both sides, and then a 3 in front of sodium nitrate, which now gives us 3 sodium on both sides, as well as 3 nitrate on both sides. So that reaction is balanced.